Okay. All right, so what I'm going to do is I'm going to teach you how glucose is absorbed from the intestine down into your bloodstream. And so this would be target 6-3. Target 6-3 says a whole bunch of stuff you don't know anything about much, all right? It says, I can detail how a sodium ion gradient is used to actively transport glucose into these things called enterocytes, and so forth. So my intention here is just to give you the overview, and then the next time we meet, we'll get, I'll tighten it up, give it some more specific details. But the cool thing about this lesson is that it's about gradients. And I've already taught you about gradients, and I've told you that gradients are a major theme in biology, and so they pop up when you don't even realize it. All of a sudden you're talking about gradients. So it is one of those topics that you need to learn if your intention is to go on into some sort of life science. You need to learn about gradients so that you're not so you're well prepared, because they are something that is frequently used by the body, and so they're going to pop up in a lot of different conversations. Here we are, we're talking about how does the absorption of glucose occur, and it's with a gradient. All right, so first thing I want to do is get some vocab down. I've been using these terms for the unit, but I'm officially defining them for you. All right. Digestion, chemically and mechanically breaking polymers into monomers. Chemically, through stomach acid, and enzymes. Enzymes are proteins that drive chemical reactions to occur. And then you have mechanical, like the churning of the stomach and your teeth grinding food. Digestion primarily happens in the stomach. And then you have to absorb the monomers into your bloodstream. And so that's what monomers moving from the lumen into the blood. The lumen, that's a new one for you. What is the lumen? All right, this is the hollow space inside the intestine. So that picture you're seeing on the board over there, or, well, hey, I don't even need to do that. I can just say, hey, here's an intestine. You're looking down the pipe. This part right here, this hollow space, I gotta sneeze. Oh man, and it went away. I hate that. Like, now I don't know what to do when it won't happen. Anyway, okay, well, we'll just, stupid allergies. I guess this is I love this season, but it's
actually the worst feeling when you're about to sneeze.
Yeah, okay, so anyway, sorry for the interruption, but this is the lumen, that space in there. All right, I don't know why they call it the lumen. The word itself has to do with light shining. So it seems like, I don't know, maybe when you're looking down a pipe and you can see the light at the end of the tunnel. I'm trying to make a connection there. I don't know why, but anyway, that's what the lumen is. So anyway, let's build on this drawing. You've eaten food, it's been digested, and it's working its way down. Here it is in your intestine right now. Okay, and it's waiting to be absorbed, and so it's going to pass through. It's going to pass through the lining of the intestine into the bloodstream. The blood vessels surround your intestines, and that's what we're talking about here. All right, so how does that occur? A gradient. But first, let's get some anatomy down, some more anatomy. Okay, so if you were to magnify up a villus, a singular villi, you would see that the villus itself is made up of cells. All right, and those cells have a name. Those are called enterocytes. The word entero is the ancient word for intestines. So you got gastro, which means stomach, and entero means intestines. Cyte means cell. So these are the intestinal cells. And these are the cells that actually, this is what the nutrients have to pass through. On the inside of a villus, you have blood vessels. So I'm just going to put a blood vessel here. And let's say you've got blood flowing through this way. So if you are going to absorb your nutrients, these monomers moving, have to move through the enterocytes and into the bloodstream.
Would they move through the cells and then into the blood?
Yep.
How do they get in there?
That's the point. That's what we got to learn.
Oh.
All right, so how does that occur? All right, so this is one large enterocyte. If you were to look at an enterocyte really up close, you would see okay, so let's say this is the lumen here, and this is the bloodstream here. On the lumen side of an enterocyte, you have membrane-bound proteins. All right. So these are membrane-bound proteins. So okay, that's a term from the past. A membrane-bound protein. I mean, the name itself it's self-descriptive. It's a membrane. That's the cell membrane. Bound. All right. Protein. And these are protein channels or protein ports. These are ports. These are pumps. These are ports. These are the things that active and passive transport occur through. And so you have some membrane-bound proteins on the lumen side of the enterocyte, and these have a name. I'm just going to put the name right here in this. This will be a title box. They are called SGLUT-1. SGLUTs. So they're called SGLUT1s. Apparently there are 2s and 3s, different versions of these, but there was just the SGLUTs. And what does SGLUT stand for? SGLUT stands for sodium glucose transport. Because then you couldn't say SGLUT. So sodium, S for sodium, GLU for glucose, T for transport. Escalate. Yeah, it does sound kind of like an insult, doesn't it? Would you want to be called an escalate? Nah. Okay, they would be like, hey, I am an escalate. Thank you. From a long line of proud escalate people, or escalate proteins. Now, on the blood side of the enterocyte, what we have right here, we're going to put a couple of these. These are called just gluts. G-L-U-T. I do not think there's a number associated with them. Okay, what's the difference between an S-glut and a glut? There's no, yeah, the S is missing. So for whatever sodium is playing here does not play a role with the gluts. Okay, so here's how this works. And I'm going to talk about the absorption of glucose. Turns out that amino acids are absorbed in nearly identical fashion. So we don't need to talk about the absorption of glucose, and amino acids. We can just do glucose and let it stand for both. Fats, however, are absorbed differently. So we will have to come back and hit the fats specifically. But this one target is capable of dealing with both glucose and amino acids. Okay, so you eat some bread. That bread will be chemically and mechanically broken down from starch, which is a polymer, broken down into monomers. That means that we are breaking those 1,4-glycosidic linkages, both mechanically and chemically. There are chemicals that break those, and in the stomach, or coming out of the stomach, going into your small intestine, into your duodenum, duodenum. What you will have is a paste of material. It's called chyme, and it's got all those digested monomers in it. The polymers are mostly gone. So, at this point, what happens is, I'm going to show you this model. So on this model, you see the cross sections of the villi, but what I want you to notice is that you have this section right here. The villi are the thing that sticks up, but you have these depressions. They're kind of like holes or wells where the lining goes down quite a bit and then comes back up. Those are called crypts. C-R-Y-P-T. And the cells that line them are called crypt cells. So this is the crypt magnified up, and so that's a magnification bubble, and it's lined with cells called crypt cells. Now those are not on my diagram up here. Those would be down. So I could talk about it. So you've got your villi that stick up, and then you've got these crypts that go down, and then you got a villi, and then a crypt, and then a villi, and then a crypt. So the cells that line the crypt are called crypt cells. All right, so we're just doing a big overview here. We'll hit more fine details later on in the week. But essentially what happens is this. When you've eaten this bread and the monomer paste is now inside your duodenum, the crypt cells begin secreting salt water. Copious amounts of salt water. Water's going into the lumen, and sodium chloride is going into the lumen. Now, the chloride doesn't matter, but the sodium does. So what you have filling in the lumen, all right, you have lots of glucoses. So let's just put G here. These are your glucoses, and we need those glucoses to be absorbed. what happens is, this area begins filling full of sodium ions. Because that's what salt water contains, water, sodium ions, chlorine ions, and we're just ignoring the chloride ions because, dang it, I'm so used to writing NaCl. All right, okay, so this area begins to fill with sodium ions, and what will happen is, the sodium ions, you've got brackets mean concentration. So you've got a high concentration of sodium out here in the lumen, but inside the interocyte, you have a low concentration of sodium ions. So if you've got a high concentration of sodium ions out here and a low sodium ion concentration there, what do you got? You've got a, starts with a G. Oh, okay, I didn't hear you. Okay, a gradient. Yeah, you got a gradient. What's going to happen is these sodium ions are going to start running through. They're going to start running through into the cell through those escalates. Right now, those escalates are just passively letting the sodiums go down the ramp. Okay, now we'll talk about specific details later in the week, but the flow of sodium ions capture the glucose, and the glucose goes in as well. So the glucose gets caught up in the stream of sodium ions that are going into the cell. And therefore, we have a new term for you. This is called co-transport. The glucose is co-transported. It's caught up in the sodium stream. More on that later in the week. But as the stream of sodiums goes into the interocyte, glucoses get caught up, and so what we're getting into the interocyte is quite a bit of glucose as time goes on. So this area begins to fill with glucose. The sodium, it's also filling with a lot of sodium. All right, so what we've just done is we've moved a bunch of glucose from the lumen into the interocyte. Now, those glucoses then pass through into the bloodstream. They go through the glut. Sodium is not needed at this point. So, kind of two stages there. Co-transport through the escalate 1 into the interocyte, and then just diffuse through the gluts into the bloodstream. So that's the big picture. Now there's a lot of details I left off, but this is just a big overview. You have this steady flow of sodium ions into here. And then the sodium ions also penetrate through and get into the blood, and then are recycled, kicked back out by the Krebs cells, and the sodium is constantly being taken from the bloodstream into the lumen and then back. So your sodium ions will be constantly cycled. All right, so why that's not called an escalate, I don't know. It's just not. I don't think co-transport this is not co-transport here. I'll clear those details up later in the week. But this is a big picture. Your body just makes a gradient out of salt water. And as that sodium goes into the interocytes, it carries glucose with it. Now, I want you to notice something. That took way less time to talk to you about than going back and talking about originally what gradients were and so forth. Because you already know what gradients are, and that's the point. Because you learn about gradients in the first semester, it makes this job way easier, and that's the point. What I don't have is a bunch of people sitting out here going, what's a gradient? What do you mean by gradient? And we don't want that. That's undesirable. There will be so many lessons in biology that begin with a gradient occurs. And that's why they're so important to learn. Okay, so that's a big overview. More details coming in the next few days.